So, hello everyone. In this lecture, we are going to study symbolic mathematics. So, before starting symbolic mathematics, let I draw the box first and try to write what is uh, being used in symbolic mathematics. So, first I write symbolic mathematics. So, in MATLAB, generally all the calculation are done numerically. That is, for every problem, the answer obtained is a numeric value. Another way of calculation is symbolic computation. That is, the computation is done symbolically. For performing symbolic computation, symbolic mathematic toolbox is available. This toolbox specifies a data type in MATLAB called a symbolic object. This data type stores a string representation of the symbol. The symbol as object are used to express symbolic variables, expression, and matrices. The difference in numeric and symbolic computation is illustrated as, since we have used so many mathematical commands in MATLAB and we have checked that the result is in numerical form. Now we want to do mathematical operations such as integration and differentiation. So in that case, we can use symbolic mathematics. So there are two functions in symbolic mathematics. First one is um, SIMS, SYM, and the second one is SYMS. So SYM function is used to create a symbolic number, a single numeric symbolic number, variable and object. And the syntax is SYM. And in the similar way, SYMS function is a shortcut for constructing a number of symbolic objects. So Sims, this is used for creating number of objects, multiple number of objects, and this is for single objects. So let's try to use these function in MATLAB. So if we take a square root of any number, let's say we take s is a equal to square root of sqrt of 10, and this will give the value 3.1623. And if we want to show this as a like that, if we want to show this under root of 10 like that, this will give you 3.1623, and we want to represent this in this type. So we can use sims command like that. Let's take a equal to sim sorry sqrt sims and pass the let's take value, we want 10. When you enter this, and when you, let's wait for a few minutes because MATLAB is busy in doing computation. So you can see over here that a stores under root of 10. This is the way symbolic mathematics toolbox work. So this is the example, first example which I have given you. Now we want to calculate, next we want to calculate a equal to 9 by 5, both in symbolically as well as in numeric value. So we can simply write a equal to 9 by 5, a equal to 9 by 5 This will give you value 1.8, and we want to represent this a as a symbolic of 9 by 5. So we have to write a equal to sym of 9 divided by sym of 5. This will create symbol 9 and 5, and when you hit enter, then a will store 9 by 5. I hope this sim command is clear to you. Now if we want to create next, we can solve another example, which is we have to find b, which is equal to 6 by 5 plus 4 by 3. We have to do computation both in symbolic as well as in numeric way. So we can simply write b equal to 6 by 5 plus, or you can put 6 by 5 in bracket, then add 4 by 3. In another bracket, take 4 by 3. When you execute this, this will give you complete solution of that command, that is b store 2.53. If we want to use this in the form of objects, or that is in the form of symbolic objects, so we can make the command b equal to sim 6 divided by sim 5 plus sim 4 divided by sim 3. This will give you the same expression which is written over here, the same expression will be obtained when you enter it. I think this performs addition of both these value and will give the result in the form of single 13 by 38 by 15 form. I hope this sim command is clear to you. Now let's try to do some mathematical computations using symbolic mathematics. Calculus using symbolic mathematics. Now the first one is differentiation. If we want to find the differentiation of any um, time signal, so let's start with, first wipe out the screen, clear the workspace, and clear the command history. Now we want to find the um, differentiation of sine t. So differentiation can be find, uh, first we define symbolic variable, that is t, and we define x equal to sine of t there is some error. Actually this, first wipe out this, clear workspace. Now syms t, define a variable t in symbolic form, and now take x equal to sine of t. When you enter it, then x store sine t. Now if we want to differentiate this sine t and want to store this result in y equal to differentiation of x, when you execute this, this will give you cos of t. You can simply see that when we differentiate this sine t, this will give you cos t. Now we want to differentiate again and store this in z. We want to differentiate y and store this in z. This will give you minus of sine t. I hope this differentiation is clear to you. Now for differentiation, we have three different statement of differentiation command. First one is diff of x, where x is a symbolic expression for which we have to find the differentiation. Next command which we can use is diff of x comma n, where x is same, that is a symbolic expression, and where n is the order of basically the order of the derivative. And the third command is for differentiation is we can use is diff of x comma n comma v, where x is symbolic expression, n is the order of derivative, and v is the variable with respect to which derivative is to be evaluated. Now let's take one example. First I will wipe out this command window and clear all the variables. Now let's define SYMS, two variables, two symbolic variables, that is T and W. Undefined function of variable. So there is no need of putting that comma. So we define two symbolic objects, that is T and W, that are stored in workspace. Now we have one expression x equal to sine of omega t, where it w into t. When you execute this, x will store sine t w. Now we want to differentiate this x of order 2 with variable. I think we want to differentiate with respect to t. When you enter this, this will give you the second order derivative of x with respect to t. And if we want to differentiate with respect to w, and the order we take it here as 1, when you execute this, this will give you the first order derivative with respect to w. I hope this differentiation is clear to you. And the next computation we can do is we can take one example for differentiation. Let's take an example. Example is we have to calculate, we have to make a equal to x to the power n, and we have to differentiate a with respect to n and x both. Now we can make code of this. We can start making, and we can start coding for that. So first clear the command window, clear the workspace. Now we have to define two symbolic objects, that is x and n. So here we define SYMS. Since we have to use multiple symbolic objects, so we have to use a function SYMS and take two variables x and n. When you hit enter, this will store x and n as a symbolic objects. Now we define a equal to x to the power n, and when you hit enter, this will store x to the power, a will store x to the power n as an object. Now we can differentiate. Let's take differentiation with respect to x and y equal to diff of x comma first order we take, and with respect to which variable? I think we have to take with respect to, sorry, no, here x to the power n is stored in a, with respect to x we have to take. So when you hit enter, this will give you n into x to the power n minus 1, which is the differentiation with respect to x. So now we can compute the differentiation z with respect to n also. A is the expression, first order derivative we need, and with respect to variable n. When you hit enter, this is the final output, x to the power n into log of x. I hope this differentiation computation can be easily solved using symbolic mathematics. You can take any other example also. So now next is integration. So to perform integration, you have to use the function int. So I will take the example of integration. First I will define the command for integration is int x, where x is the symbolic expression whose integral is to be obtained. Next we can use int x comma t, where t is the variable for integration. X is basically same symbolic expression whose integral is to be obtained. Now we have some example over here. The first example is we have a equal to cos of x, and next example is we have a equal to x square, and the third example is we have a equal to cos of omega t, and the next example we have a equal to 3xt plus 4t square. Now we have to integrate these all the four expression with respect to in this we have to we have to integrate with respect to x. In this also we have to integrate with respect to x. In this we have to integrate first with respect to w, and then secondly with respect to t. Similarly in this we have to integrate with respect to x and then with t. Now let's try to code. So first I will start with the cos x symbolic expression. So we define sims of x and store a equal to cos of x. When you enter it, a will store cos x. Now we want to integrate a with respect to x. When you integrate, this will give you sine of x. Now let's take second example. Here we have a equal to x square. So we define sims x as a symbolic object, and now we store a equal to x square. When you hit enter, then a will contain x square. Now we want to integrate this. Since there are no other variable or no other object, in A, so we can directly use int of A command, and when we enter it, it will give you x cube by 3. Now next example is sims. We have two object, that is w and t. This will store w and t in workspace. Now we can store a equal to cos of, we cannot write directly wt, this will give you an error. You have to put a multiplication sign over here. When you enter it, this will give you a cos tw. Now we can integrate this and store this in y equal to integration of a with respect to which variable you want. I think we want with respect to t first. When you enter it, so your answer is sin tw divided by w, and we want to store integration of this a with respect to w. When you integrate it with respect to w, I think the answer is sin tw divided by t. So the next example is, we have two symbolic in this expression, that is x and t. So first define, first wipe out the workspace. Now so first define syms, two symbols, that is x and t. Now we can define a equal to 3x into t plus 4 into t into, or you can take it t square. This is the expression which is stored in a. Now you can integrate it, integrate a with respect to, first let's say we want integrate with respect to x, and let's store this result in y. When you integrate this, y will store this t x bracket 8t plus 3x divided by 2. Now we can also find integration of this with respect to t also. So we assign it in z and use integration of a expression with respect to t. When you enter it, this is the result for integration of the last expression, which is this one with respect to t. Now we can also perform definite integral in this symbolic mathematics. Let's try to check what is the command and what are the things required in symbolic definite integral. Now to perform definite integration, we have to use the command, that is int x comma variable t comma a comma b, where x is a symbolic expression, a and b are the lower and upper limit of the integration, t is the variable for which integration is to be computed, variable of integration t. So we can define x equal to symbolic expression and a t is the variable for integration, a is lower limit of integration, and b is upper limit. So let's try to solve some of the examples. So now these are some of the example of definite integration. Let's try to solve uh, one by one all the examples as mentioned here. So the first one is we have to integrate x to the power 5 with respect to x from 0 to 1. Now first clear out this command window and wipe out all the variables. Now let's try to code this. So first we have to define syms a symbol x or object x. Now we have to integrate this y equal to, we have to define integrate the simply x to the power 5, or let's take first function a equal to x to the power 5. So let's try to solve first example in which we have to integrate x to the power 5 from 0 to 1. Let's define syms x as an object, symbolic object. Now we have to define x to the power 5 as an expression, a equal to x to the power 5 as an expression, and now we have to compute the integration of this x to the power 5. Now y equal to int, we pass first a, that is the expression for which we have to evaluate the integration, and then the variable with respect to which we have to take the integration, that is the x. Now the lower limit is 0 and the upper limit is 1. When you execute this command, this will give you the result, that is 1 by 6. Now try to solve the second example. Here we define syms same x and define expression which is exp of x. X is already stored object, so we can form like that. Now we have to define y equal to integration of this expression a with respect to x and the upper and lower limit. The lower limit is I think 0 and the upper limit is 1. When you execute this, this will give you exp1 minus 1. I think this integration is clear to you. Now next try to solve the third example. Here x is the variable, x is the object, the symbolic object which is already stored in this. So we define only a expression, that is sine of x, and we enter it directly. A will store sine x. Now y will store integration of this particular expression a with respect to x and the lower and upper limit. Lower limit is 0 and upper limit is pi by 2. When you hit enter, this will give you the result 1. Now let's try to solve the last example in which x is the symbolic and which is stored in x in the workspace. So we can directly take, here log is of base e, so we can take expression a equal to ln of x. There is some error. Instead we have to take log, a equal to log of x. When you enter, this will be the expression, symbolic expression which is stored in a. Now we have to integrate it, y equal to integrate this expression a with respect to variable x and lower and upper limit. So lower limit is 2 and upper limit is, sorry, lower limit is 0 and upper limit is 2. So when you execute this, this will give you log 4 minus 2. I hope this symbolic differentiation and integration and definite integration is clear to you all. Let's take solve command for solve command used in symbolic mathematical operations. Now there are two expression of solve command for solving any symbolic expression. The first one is solve f, where f is an algebraic expression or symbolic expression, or you can use the second command, which is solve f comma a, where f is the algebraic expression and a is the variable for which solution has to be obtained. So let's try to solve some of the example. The first example we consider is we have an expression f equal to ax square plus 3x into b, and we have to find the value. We have to solve this expression for x. Solve for x. So let's try to code this. Now first I will clear the workspace and defining three objects, that is a, b and x. Now defining the expression f equal to a into x square plus 3 into x into b. This is the expression of f. Now we want to solve f for we want to solve f for the value of x. So we can write solve the expression f for variable x. When you hit enter, this will give you two value of x, because we have equation, this expression is in x square, so we will get two values of x, that is 0 and minus 3 into b divided by a. Now we can solve this expression f for a also. When you enter, this will give you minus 3 into b divided by x. You can solve for any particular variable or object. I hope this example is clear to you all. Now let's try to solve another example. The second example is this is the first example. We have the second example, which is f equal to 4x square plus 3a plus 2. We want to solve for a as well as for x. So let's try to solve. First I will clear the workspace, clear the command window. Now I will define syms. We have two symbols, that is x and second one is a, and now defining f equal to 4 into x plus 3a plus 2. When you hit enter, this expression is stored in f, so we can solve it by using solve command. And you can assign any variable for solution. Let's say we take x, or let's take y, because x is a symbolic function, so it will override. So let's take y equal to solve expression f with respect to which object. First take x, then you hit enter. This is the result which is stored in y. Now you can take for A also. When you hit enter, this is the result for A. I hope this symbolic mathematics with all the integration, differentiation, and definite integration and solve command will be clear to you. So thank you very much.